Hey, what's up, Ziguanas? This is day 18 of the 30 days of Zig Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Just one thing before I move on today's topic in coding. I would like to explain to the ones that are here for the first time the idea behind this 30 days of coding Zig challenge. So the idea is that I document my learning process, learning Zig, of course, and why this is maybe interesting to some people is because I have a lot of experience in the industry, and I've learned dozens of different languages in the past, and I worked professionally with a few of them. And I just want to share how I would approach after all these years of experience, and also from the other side, because I was teaching, I don't know how many hundreds of students so far, and I know what were their questions, and I've taught from beginners to senior developers. I've mentored some senior developers for some specific things, so I kind of have the wide range of experience with the different levels of people who want to learn coding. So I know what are the most common questions, and I know what are the most common pitfalls when it comes to learn a programming language, especially if it's the first language to someone. And that's the reason why I'm focusing on things, how I would do a new language. And of course, I adapt this a little bit because I'm streaming live. So usually what I would do if it wasn't streaming live, I would actually do much more time. I will spend much more time revisiting the things that I've learned. So if I just like go once through some topic, I would just go back and repeat and practice more. But I think this is a little bit boring to stream, so that's why I kind of like go a bit quicker through the topics, so that it's not that boring maybe to some people. And that's why I move on just like a bit quicker, and I don't document. I mean, there is nothing else to document because I don't do anything offline outside of the stream. I try not to touch Zig outside of this stream so that it's realistic, that you can see my progress from the first day, and then how I progress and what will be my level, let's say, of Zig knowledge by the end of the 30th day. So hello, Control Shock, welcome. So that being said, this is not a tutorial. I do plan to make one after I finish this challenge of 30 days. I will start then practicing more offline, and then I will write as I go for the second time through all these topics. I will I will create a video tutorial from the beginning for anyone who wants to start learning Zig as the first language, or maybe as a second and third language, and that's the idea. Okay, so let's jump into the coding part. So today I will do pure type resolution from the docs. I'm almost done with the docs, so there aren't too many things left. I will probably make it in time by the end of these 30 days. So I hope I will cover most of the topics, at least, if not all of them. So let's see here what this pure type resolution is about. And yeah, one more note. I have never worked professionally with the low-level things, like I've never coded some embedded things and so on. So I'm a web developer. So that's why I didn't use some parts of Zig. For example, I learned C when I was studying at my university, and that's the last time I touched pointers. So that's why if you watch my videos here like a few days ago, you will see that I remember something, but I forgot in general how the pointers work. Some parts of it in C, and of course in Zig it's different, so I have to learn the Zig way of doing things. Let me see what you wrote, Control Shock. I'm really interested in computer science, and I'm planning to pursue it, but the recent AI and job scenario is stressing me out. Can you give me your advice, man? Yeah. So I don't know if you heard about a company called Build AI. So they rebranded it. It was called differently before. And basically what they are doing, they are kind of like the opposite. So everyone is scared if AI will steal their jobs. But what actually this guy did, they kind of like took the job from AI. So they were posing as AI company that has developed some advanced AI agents. But actually what they had in the background is like 700 people running, like coders, humans, that were receiving these prompts from users, and they were actually coding and sending them. So it was crazy situation. So we are not near that. I don't think we will be in the few years, for sure, on that level that you can completely replace developers. And if you can, basically they will replace anyone then, because nowadays you have, for example, you have robots that can perform surgery on humans, and you can control them remotely. So if you have everything like a machine that can operate on a person, then you can code it as well. You don't need even like the surgeon, sorry, to operate it. If there is some very specific things that needs to be done and some sensors, they can easily just automate that as well. And I've seen some videos about people who are completely not software developers, so they're more like marketing and product managers and all these, let's say, managerial positions. They are doing a lot of things without need to hire humans anymore. So they are speeding up the process. So when I say without hiring, basically you are speeding up things. So you don't need to, you don't replace completely humans, but you speed up your working process, whatever it is. So for example, if you want to do some image generation, that is now much faster than if you do it manually. And also if you code, AI can help you to code much faster. So you should think about it in this way, that it's very useful for the productivity, so that you use AI in that way, not to depend fully on it, because it cannot do everything precisely. And I would never trust the code that is written by AI, and I wouldn't sell it to my clients as is. I will have to definitely go through all of it and then see if it's safe and everything. But you can for sure use the AI in your advantage, so that you speed up the things that you're doing. So in our job, like as developers, it's a very useful tool to speed up the boring stuff. And also in other branches that I mentioned. So you have either music makers, creators, whatever, like artistical part of the AI is also very useful for this kind of applications. So you still, of course, if you wanted to, for example, make a film, a movie that is like 2 hours long, which would be like very high quality, that you can compare it, not let's say to Hollywood movies, but let's say something like maybe some festival movie, that quality, you can do it with AI, but you would spend so much money because you will have so many results that are like a man with 3 hands and so on. So they are fixing these issues, of course, but it's still not that close that you can be sure that it will have consistent results, and that you will not have any weird results. So that's why I've seen some amazing AI movies done completely with AI, but you can tell that this is AI still. So yes, it is okay if you have something, for example, if you have a very limited budget. So for example, you cannot afford to pay some 3D modeler or some designer. Of course, then you can prompt and generate your images or videos, and they will be like, the quality will be good enough so that you can use them, especially if you like retry prompts. And it's the same with coding. So sometimes, depending on the error that you're having or whatever that you whatever is it that you need, you will get some more or less useful guidelines how to solve something. Sometimes it will solve your problem in a second, but sometimes it will just like run in circles, because especially if you're working with something that is, let's say, experimental technology, so some, let's say, new language, new frameworks where there is no documentation online. So basically AI cannot do that. It depends on the existing knowledge. It cannot be creative in that way like humans can, so that you can think outside of the box. So it literally like just has a large library of all the knowledge and then uses the known things. So for this reason, you are still safe for the foreseeable future. And like I said, it's not only us. If the AI comes to that level that it can replace completely developers, then it will replace everyone, literally. So humans will be obsolete. No jobs for any kind. They will replace lawyers, doctors, anyone. That's the state. Hi, Robert. How are you? Yeah. So yeah, it's the same thing. Like through the history, it was the same. Like if you were doing something, let's say, if you did something, let's say 100 years ago, if you were like the guy who had the carriage and used horses, then of course when the cars arrived, they were too expensive for the masses, and they were safe for some time. And then when the cars became more and more cheaper and more accessible to anyone, then like the people who were like used to ride the carriage, they just like switched to being a chauffeur. So you will have some new jobs that will be created for this. So you will need, if they completely replace developers with prompts, then you will need some person who will know how to prompt. So it's not that like you can say like with 2 words, I would like to create something, and then it generates all the code. So this is actually the hardest part, working with people. If you had clients in any branch, not only in developing, you probably know that when you ask a client what they want, they cannot answer. Like in 80% of the cases, they will not know what they want, or they will just like, let's say, I want everything. So I want the sites, for example, if you're a web developer, they'll say like, I want this, and this. Look, I want a Google on my domain. And then when you explain them how difficult it is to create something like that and how much it would cost, then they are like surprised. And this is like typical customers. So they don't even know what they want and what they need. So good luck with that. If you find an AI and you have a human that knows what they want, then yeah. If you decide to pursue computer science, I recommend going deep to not get stuck at the high level and to try to truly understand the way how stuff. Yeah, that's a good advice. Yeah. So the point is that you become an expert, and the more niche thing you're expert in, you will be more safer from AI. So if you are, for example, now you start, I don't know, you can find the language. Not like Zig is also like 1% and 1.2% people in the world on Stack Overflow survey uses Zig, of all the developers that were participating. But you have some more exotic languages like that are not even on the list on Stack Overflow. So if you learn one of these, simply AI will not be able even to tell you and to help you with it at this moment, because it doesn't have any docs to read from. So you have to experiment, and that's not something that AI can do well. So the more, let's say, hidden the knowledge is from humans as well, then it will be also, it will last longer against the AI. And what we can do also, like if we want to let's say save our jobs and everyone's also, we can just like post false answers on sites like Stack Overflow, and so of course this is a bad thing to do, but I'm just giving an example how you would confuse AI, because they train it on all these websites. So if, for example, I ask a question and then you give me a wrong answer, and everyone likes, because we know that it's wrong, but we want to confuse AI, like we have a deal, all the developers in the world, then it will be completely useless in the future if they train the AI on all this. And they are doing this. So they are training it on Reddit posts, on Stack Overflow. So they are training AI on these kind of things. So then it will be completely useless. This is just like thinking for fun. I'm not actually suggesting to do this, but just like we speak like what if, how we can survive like the revolution against the AI and so on. Also, don't get discouraged. You might not understand something at first. Everybody was at some point. Yeah, I'm new at some point. Yeah, I'm now, for example, I'm new at Zig, and Robert helps me a lot. So there are so many things that I don't understand still, how they work in Zig. It's literally like my day 18 working with Zig, and still not understanding a lot of things, although I have a lot of experience in different languages, but simply it's a different language. So yes, I do have some basis. I understand most of the concepts, but there are some completely new things that I've never seen before in any other language, and I have to think really hard to understand and practice. Like before I can implement them, it will like a lot of time has to pass. I'm currently learning C. I'm really enjoying learning it. Yeah, that's a good start. So C is the typical university language that they teach because it's so closely related to underlying assembly and machine language. So it's a good even if you, for example, if you find in the future very hard to if you in the future cannot find any jobs in C, it is good to develop this kind of thinking and to use it as a theoretical language, at least, if not something else. But it's still used in the industry. I'm just like hypothesizing what if they completely stop using C, which is technically not going to happen in the near future. But even then, it's a good thing to learn, because you learn this theoretical concept. At least it would be theory in that moment if they're not using it, because it's a pretty schoolbook example of how programming was back in like 50 years or so, how they optimized the code that used to be assembly to a bit higher level that is C, so that you don't have to write, I don't know, 20 lines of code for a loop. You can write 4 or 5. So, and it's much more readable. Like it's English, you understand. While it's easier to understand than some jumps or other things in assembly, and it's easier to control. Great choice. C really shows you the stuff, even though it might be a bit daunting that you often don't see the immediate impact. Yeah. C was also my first language. Yeah, so I remember when I was studying, it was the first language that we learned was C. The second was C++, then we learned Java and so on. So that was in my at my university, how they taught. And when I was in high school, I actually learned Pascal. So that was the first language that I learned in a school. And actually, the first language that I ever learned was BASIC for Commodore 64. I'm a little bit older, so I coded the first time on Commodore, first BASIC, and then I integrated some machine language assembly for Commodore 64 to do some specific things. To, for example, change the font, because you didn't have fonts. Like the concept of fonts didn't exist. It was like 64 kilobytes of memory in total, and some of it is already like used, so you cannot even use all 64. And then you don't have fonts, like you have to hack. I mean, not hack, it's officially what you do. You find in the memory a location where there is like, where there are zeros and ones that represent your A and B characters on your monitor, and then you change them. And this works until you turn off the computer. So then when you turn it on, it forgets everything, and you have to, of course, load the code again into the memory manually and so on. Okay, so let me jump a bit in Zig, see what we have here. Pure type resolution occurs in these places: switch expressions, if expressions, while expressions, for expressions. So loops and basically branching part, multiple break statements in a block, some binary operations. This kind of type resolution chooses a type that all pure types can coerce into. Here are some examples. The examples. So here, this part, actually let me copy. Yeah, this is, I think, one part of it that I can test. And let's, yeah, wrong function. Sorry, this was from today. Let me undo. I will delete this part. And I wanted to do it here, actually, in the main function. Okay, so const A, I8, which is 12, then B, I16, which is 34. Then they make const C, which they assign the sum of these two. Then they expect C to be equal to 46, which we can see it is the case. And then they ask what's the type of C, and it's I16. Right. So we had here in the expression, we had one I8 and one I16, and the result is I16. That's the point, right? And they call this pure type resolution. And this, in this case, they say this is pure resolve integer widening, which I remember from previous, I mean, yesterday or I forgot when they say widening, they mean actually when you convert I8 into I16, for example. So if you go higher, higher types. So the only thing that I see widening is here the A, which is I8. So I guess they are here in this expression, they are widening it to I16, then they summarize, then they assign to C. Looks like it. And then if I just print the type of, let's see if we get what they, oops, this should be print, not type of C. And let me comment these. And let's also print C. I mean, it's simple, but just in case. And let me see what you wrote, guys. Thanks for your advice. I'll be able to sleep peaceful today. Yeah, that's a good thing always. Probably wish you best of luck. Yeah, me too. Thank you. Also for C, Raylib is great library if you ever decide to make some Windows stuff. Raylib, I'll watch about it on YouTube, bro. Thank you, bro. All bros, that's a cool thing when you are in this world. So yeah, this is what they expected. 46 and I16. Cool. Then let's do the next thing. Pre-resolve arrays of different size to const slice. Okay. And let's just see what they... now they are trying this inside of the comp time. So basically what they're doing, they are here using this bool to string. Where is... here it's defined. Yes, so in this case I will have to copy paste a bit more of the code, at least this part, for this thing to work. And I guess these other are different. Yeah, so let me copy this one. And let's see what it does before I run it. Bool to string, okay, pretty clear name. It receives a bool, it returns, because there is no type of string right in Zig. This is what you have under the hood. So constant array of U8s, right? Constant slice, yeah, this is like, yeah, I keep forgetting. So this is when there is empty square brackets, it's a slice, not an array. Okay, constant array of U8s. Yeah, by the way, Robert, I found the solution when I finished the summary, the second summary. After the live stream, I asked Gemini about the problem that I had, and then I solved it basically with this. Like, this was the function signature, so the parameter was like this, and then down there also I changed a bit in the call. Let's see what is next here. This part. Yeah, that's how I like to use AI. So I don't like to use it to write me code completely. I just like to consult it when I'm out of ideas. For example, first I like to try on my own, even if it will take me longer. I like to test things on my own, if I have time, of course. If it's something like rush, you have a project for a client, then of course I will do everything to speed up. But if I have time, I will always choose first to play with it a little bit, to test things, break things, and then if I'm out of ideas, I ask AI to help. Sometimes they do, sometimes they don't. Let's copy this part here, and let's see what they do. So they convert this to, coerce this to true, and they ask if it's equal to the string that contains true. So let's just do this instead. Then they do the same thing to false. different example. Then what they do, they compare if they're equal. So if this is really equal to this, so we can do the same in a bit different way. So I will just change this into the shorten it up. And here I'm going to ask if this is equal, what string to write, yeah. And the same thing for the false, but it will be just false. Okay, so I don't need this anymore. And definitely I will comment this and leave just for the reference. For strings, let's say, aha, okay, that's why they use this equal. M equal. Okay, okay, yeah, because I forgot they are not strings, they are array, or in this case, constant slices. So it's not something that you can. So in C, you can do this. In C++, you can overload operators and you can make this actually compare anything you want. But in this case, that's not the case. So you have to do something like this. So I will have to import. Let me copy from them. It's easier. This part. And then I will do this instead for this one. Then this thing here. They did not make copy paste mistake. What does it say? So I did. I have some. Let me just double check. So this part here, if I delete, yeah, this seems to be fine. Then mem equal, did I import it right? Yes, as a mem. Okay, so then equals u8 bool to string true and true. What they say in 18. So here, yeah, it's in this line. Expected closed parenthesis. So which one I'm missing here? This one is closed. Then I have, aha, so this one. So here I'm missing. Yeah, I'm always doing these things. Did I? Yeah, no, I think I did it right. Identifier. Ah, I didn't import it as std. So I can do basically this instead, just speed up things. Or I can import std itself. It doesn't matter, it's the same. What does it do now? Ah, okay, s and any, which line? So let's do this here. Yeah, they don't say which line. Oh, no, they tell 24 is mine. No, this is in the writer. Okay, I will just do any here and here. And this should be equal. Slice without. Aha, so it's about slice. Where do I have the slice that I want to format? Slice cannot format slice without a specifier, but where do I have the slice? So this is bool to string. Aha, this is generating this. Okay, so here, if I'm not mistaken, let me see. Yeah, okay. Let me see if you wrote something, guys. Yes, we could have told you, but guessed it might be better for you to find out, to remember. Easy way to determine it between slice and an array. Slice is a pointer and length. Yeah, remember that. Also known as fat pointer. I can have runtime known size and does not actually hold any data. Array has compile time known size and holds the data literally. 5 U8s in an array is a block of 5 times U8 in memory. Yeah, 5 bytes, okay. When you pass them around in Zig without stuff like star operator, they are passed by copy. So you have such a treasure here in your comments, and not only today, but also before. So I will definitely, one day I will just go through these videos and I will just read your comments to memorize these things, because they are not speaking about all these things in the docs. This is coming from your experience. So you literally copy the in-memory array, or you copy the fat pointer, which does not copy the real data it points to. Yeah, so it's kind of like not deep copy. Okay, thanks. Let's see the next thing. So yeah, by the way, I didn't even see. Yeah, this is true. So it's true that this is false. Okay. And the first two, so again, these are Unicode ordinary numbers of these characters, which are TRUE, and then here FALSE, right? So E and E, at least we can see they're the same. So we are going to trust them. Trust me, bro. Okay. Let's see the next thing. Here resolve array and const slice. So they do call this test peer, which is this function here. And here they are using the same. Yeah. So then I need this one. And I need, yeah, I actually didn't, just before I do this, I just want to quickly go through what's happening here, because I was distracted by the error and I completely forgot to see what's actually happening. So basically they call this function here, which receives a boolean and returns the slice of U8s, and then they do return if B. So they literally ask if this is true, because this can be only true or false. So they ask if it's true, then they return this part here, a string literal true, which basically under hood is a slice of U8s. So if this is not the case, if you receive a false, then you literally say else return false here. So that's why here we are getting the slice of TRUE as U8, and here the false, and here they just compare. So mem equals, they compare as U8s if these two and these two respectively are the same. Okay, that makes sense. Now I can move on. It was this, yeah, this was the function that they want to use, and this is the testing code. And I will do that here, and let's comment out. And let's see what they want to do. So this I will delete. Then let's call this for true. And before I run it, I will actually now, this time I will take a look at the code in the function, see what they want to do. Okay, and let me also copy this part just to have the idea what is it about, to even understand even easier. Resolve array and const slice. Okay, let's see. So they receive bool again. So this is a union, right? Of void. And what this means, Robert, I usually know that when they say union, there is like a non-void type on the right. So this is like weird. Why union with void? Why they're doing this? Let me see also what you wrote before. Zig tries to make stuff easy so the behavior is consistent all over the board. So you don't have to remember million rules like in C++. Yeah, that I think you're referring to this overloading the operators, right? Or something else that I mentioned. Because yeah, there are a lot of people who are saying that this is so bad idea that you overload the operators, because then when another developer sees the operator, if they don't look through your code, they will not know. They will expect some other default behavior and so on. So let me just try to see what's happening here. So B is the input, the union void is the output. And let's see what they are doing this here. They're calling the function for true. And they are trying test peer resolve are equal. Okay, this is just the name of the function. And this is during the comp time they're trying to call it. And let's see what happens inside. So the first constant is the value 1. And that will get some value that will depend on this condition. And the condition is if B, so if the B is true basically, then it will have the value, 1 will have the AOEU as a const slice, right? Well, actually the array in this case, because it's literal should be array. Else then they convert it, yeah, here is where they convert it to a constant slice of U8s. So they take the other different literal, not the same, not AOEU, but ZZ. And then, because this is a string literal, by default it will be array of U8s, but then they use the as built-in to coerce it into the constant slice of U8s. Okay, and I guess here is the similar thing. Let's see, value 2, the same condition, if true, then, so they just do the opposite here. So here, if it's true, value 2 will get what value 1 gets if it's not true, and the other way around. So basically, they kind of cover both of the possibilities with these two values. It's just like which one will have which one. And then what they do, here they have also expect. I just thought that they're expecting here, but they actually do it here as well. So they try to see if they're equal. If value 1 is equal to A or EU, and in this case it will be when you send true and they send true. And then the next one is asking if value 2 is ZZ, and that one will be if you send here the true to B again, right? So basically both times it will be the case. Let me see what you wrote. It doesn't have operator. Yeah, that's what I noticed, that it doesn't have, just like the C++ has it. The type is error union. It's an error union. Okay. So it's void and the error. Okay. It means possible error. Values returned by the function is inferred by compiler, so you don't have to type it out. Okay, cool. Basically, it means only that the function can either return error or some other value. So then it's not basically void here. Okay. And you need to handle the possibility of it erroring on call site. Okay. Yeah, you see, like I already forgot, like I did this error unions a few days ago, and because I didn't practice, I didn't use them. It's like going out of my mind. So I'll have to play with them as well next time I do the summary. Okay, so then basically this is only it's important only because they send these values so that you understand what's happening here, but I went through it, so I don't even need to refactor this code so that I run it. It's clear what will happen. Let's go to the next one. Peer type resolution. So this is optional T and T. What is this? I'm seeing this for this okay, this is the closing string. I was like, what is this now? Like, is this like lifetime in Rust or what is it? Okay. Let's see what they do. So they call peer type an optional T. So this is the same function, so this one, right? And then this is a different example. So I need this function here. And then this part down. Actually, I will copy the first line as well, and I will comment it out to see what they want to say. And this one, let's comment out. And let's see what they say. Peer type resolution. Wait, did I copy the right one? Yeah, I wanted to copy this one. I copied the wrong one. So this one, not like this. Yeah. Oh, yeah, this is just like, I don't need this, but I will comment it out anyways. You can think of it as throws in Java. So it's kind of like you don't handle it in the function itself, you just like delegate it to the higher level where it was called from. But it signals to the compiler and programmer that the function can fail. Cool. And type in exclamation type is the value it returns if it doesn't fail. Okay. So fail or this type. Yeah. Okay. Thank you. Let me see now what they are trying to do here. So first of all, function. 2 parameters, both bool, C and B. Optional use size. If C is true, return. And then they have this expression. If B, basically if both C and B in this case, you return null. Else, which means only C is true. Then you take 0 and you cast it into use size because 0 is comp timed, right? So you cast it into, you coerce. I still say cast because I'm used to some other languages, but yeah, I think this is here coercion, how they call it officially. So they coerce to use size, and that's what they return if B is not. So true returns null, true false returns 0 as use size. And if not, so what is the remaining combination? So we covered both truths here. So basically when C is false, right? And no matter what is B, if C is false, then this. In this case, similar to here, comp time int to use size, and they return that. Okay, and then let's see what they do. They compare true and false, which is basically this, right? So it should be 0. Yeah, they say 0. Then they do the same for false, which is this third case that I explained a second ago. Then, okay, this is comp time. Now during the compilation, the same, not the same. So this is actually true, false, and here it's, no, it's the same. I'm blind. So false. Yeah, they're the same, and they provide the same results during the comp time and the runtime here. And let's see just one more time. And what they say also here type resolution, optional T and T. Okay. So if I'm not mistaken, this is just like, this part is interesting because they are expecting an optional type of use size here, but just as an option, not as a concrete type. And here they are returning use size, not an option, but use size. So then it's coerced, right? Or how they call it, peer type resolutioned, or how would I say? Let me see what you guys wrote. And yeah, by the way, I don't think you need the as casts. So it's automatically happening, you think? Okay. And by the way, did you notice, I'm just like curious, I might have mentioned before that I work with Solidity, for example, in blockchain. And I remember when I started, Solidity didn't have safe math. So you had the overflow and you had to worry yourself about it, or you could use the third-party library to just like make you do the safe math. And then they changed it in some version. I forgot which one. Later, I've noticed that you basically can do now the safe math in Solidity. And some other changes that are, some of them are kind of breaking changes. Some of them are just like expanding, and they give you more options. So do you, Robert, remember something? Hi, Samarjet, sorry. Welcome. Do you remember maybe, Robert, any example of the change that you remember from any version of Zig to any newer? Just like to have an idea how much they changed. If you notice something, it would be interesting to understand how they think, like what they changed, and what I can expect maybe to be changed in the next version. I mean, I know it's so the same like with Solidity. Solidity is still not version 1.0, so it is quite subjectable to changes. Like who knows how they will change it. And I expect the same from Zig, because still not 1.0. But it's interesting. And let's see just the next thing here. So where is this here? So this is the function. It's always below. It's like weird that they use the functions that are below. I'm kind of used to that they're before. Yeah, so this is the one, and they only need this one. So let me copy here. And let's do this one. Ah, this is my, again, because I expect it to be before. So this is the one that is attached to this function. I'll probably not run it, but anyways, I will leave this print just in case. Comment out these. And let's see what the function does. Pure type empty array in slice. And they want to say another version of the pure type resolution. So this is the pointer to the U8 array, right, with size 0, and the constant slice of U8s, if I'm not mistaken. Let's see what they do. So they receive one boolean, A, one slice, constant slice of U8s, and then they return the same type, constant slice of U8s. Then what they do inside, they say if A is true, they returned what they return. So this is a reference to array, if I'm not mistaken, what they have here. And it's an empty one. And then there is this resolution happening here, how they call it, pure type. And they have, yeah, it's literally saying here what it is. So empty array and slice. So they have the empty array. And it's interesting that they have a reference here, address of operator. And they then return this, but the type is different. So this will then trigger this resolution. And in the next case, so if this is false, right, if this comes in as false, what they are doing a slice, and this is the range from 0 to 1, which is then a slice, right? So it is the same type of, maybe I'm mistaken. And let's see what they send. So first they send true and slice, sorry, slice is the input here. Yeah, I completely forgot they are using the slice from here. So they're just taking the first character of it, right? Let me see. Length. They test the length. So yeah, so it is one character. So basically they are taking from the first to the first. So because this is like not inclusive, so basically first index is 0, just that one. So whatever you send, so basically this one, H, and because it's only one character, it will be size 1. In the first case, it's 0. Let's see why. Because, yeah, because they're returning, when it's true, they're returning the empty array, which is converted to slice, and then that's why they have a 0. And it's the same in comp time. Okay, let me see what you guys wrote. They generally change standard library APIs, but often support the old APIs for one more release anyway. Okay. Nice to know. And some minor language changes in past 3 releases, the language didn't change much. Okay, that's cool. Mostly name changes. Okay, GOL, stuff, and added labeled switches. So they didn't have label switches before. Okay, thank you. Okay, so this is pretty straightforward. This is from before. Currently, the compiler is the focus. Conditional compilation, faster compile times, they are tiny bit slower than C. Okay, and a lot of bug fixes. Yeah, but they are still faster than Z, right? Compile time. sorry, the Rust. I want to say Rust. My mind now I'm into Zig. Okay, so the next example would be, I think, this one here. How many? Okay, there is one more. Actually, maybe this is also test for the same. I have to pay attention now what they're doing. So for this function, empty array and slice and error. This was just like empty array and slice, and here it's also an error. So they are taking those here, and just to compare with other two tests, this is independent. I think they don't use this function, and this is also independent. So let's then do just this part for now, and then after I finish analyzing this part, I will go to these two examples lower. Here, type empty array. That's the one. The previous one. And the code, again, it's here. My instinct says go down, but it's up. Here, output and resolution. Okay, let's see what they say. So an array, pointer to array of 0 size u8, constant slice, so the same like before, and anyerror union with, this is a slice of u8s, right? So a union of anyerror and slice. Okay, and then let's see. As you said, they are still fast, but we'll go to an instant even on large projects in the future. Okay, thanks. Let's see the function. The function takes two parameters, again, Boolean and slice, like before, but this is different. So now it's a union of anyerror and u8 slice. Then they say, if true, they return again the empty array, which will be then resolved into this. Basically, because it's union, they will take this part of it. So a slice if there is no error, of course. And other than that, if A is false, they will slice the input slice. They will slice the slice. They will take the first byte of the slice and return that, which will basically, again, come inside here if there is no error. And let's see how they test. They have block here, and then they have comp time block. 2 blocks. In the first one, they say data is variable, and they take the string literal dot pointer notation to take the content of it, right, to the dereference. Then they slice that data. They take from 0, if I remember correctly, this is up till until the end, or I forgot what this means if it has some other connotation. Then they have this data and the slice, and what they send in is true and slice. So because it's true, we trigger the first branch here, and it returns the empty array, which is resolved into slice of u8s. That's why here it's true that it's slice that is equal to, that length, yeah, sorry. That the length is 0 because we return the empty array, which is resolved into slice, so empty. And in the second example, false, which means the second branch, which means they will take the first character of a slice, which is again h, and then it has the length of 1. So this is literally the same like before because they don't trigger the error. So they just have like a safer code because they are now protecting against potential errors as well with this union. But in this case, because it's valid code, we don't get an error. And the same example for the comp time. Okay, nice. The next thing is then this part here. Let's see what they do. And let's comment also one more line here. Comment the first one, and let's delete function. It's easier to read. Okay. Here type resolution, pointer, constant pointer to a type, and optional pointer to a type. Let's see what they do. So const a, the type is constant pointer to use size type, and then it's equal to pointer from integer built-in function. They use it to take the hexadecimal literal as an integer, and they coerce it, or how you say, into a pointer. That's why they attach it to a. Then in b, they have an optional pointer to a type. So literally what they say here. So the type in this case use size again, and they do try the same coercion, pointer from integer, the same number, hexadecimal. Then they have the test. They call this they call the function which I don't have, which was the one. Oh, wait, they're not calling. This is mine. Okay, this is my old code. Okay, I managed to confuse myself. So this is the only thing that they have. So they just like expect a to be equal to b and b equal to a. So that means that here we'll have this resolution between these two types because they are not the same. But here, when you compare them, it will be not coerced, but resolved. How they say, resolution. So if I'm not mistaken, yeah, first of all, I have to see. So this is a pointer from integer, but I don't know what kind of pointer. Pointer from integer, so I guess pointer to integer, but I don't know what kind. And then here they resolve it to this one. Or maybe they also want to say that here they are, when they try to compare, that the b will take an option of use size and be compared with console. So because I don't have this previous knowledge, for me this kind of sounds ambiguous. I'm not sure if when they say a resolution in this case, they're thinking about from this type to this type, or maybe from this type to upgrade it to compare it with this one, or the other way around here. So, but something in that spirit should be happening under the hood. Let me see what you wrote. By the way, I recommend to look at the case study print. It's fast and really cool. It's just reading. So let me see here immediately that I don't forget. I will leave it here so that I can examine it. Maybe I was thinking about examining it offline, but maybe I will actually do it live next time. So I will just keep it open here for sure that I don't forget. And I want to definitely read it. Okay, let's see the last part of this. Aha, here it is, I'm blind. Okay, it's literally like here, a study print in Zig. So I'm here now. This is the part that I went through. I didn't do these. I didn't do any of these. So basically, all these are new to me. I haven't touched them yet. And of course, assembly and these things below. I was just considering what is before the case study. Yeah, this is the only thing that I did here before is this part here. It's in docs, yeah. Sorry, I always find out the hard way. Here, type resolution, error union switch. Let's see this huge chunk. I mean, it's huge compared to the previous one. Not actually huge. And let's comment out this part. Here, type resolution, error union switch. The non-error and error cases are only peers if the error case is just a switch expression. So these are so like tricky details I have to memorize. So not that it's a difficult concept, but it's just like all these details, like, oh, okay, this is a special case for this. This is the special case for that. So I will confuse them for sure. So I will have to write some notes to myself about these kind of things that I memorize. The crucial things like this that will save me time and searching. So their non-error and error cases are only pairs if the error case is just a switch expression. The pattern if x block else error capture group, then the block which is labeled will then switch inside of it, and they switch the error that comes from here. Does not consider, so all these things together as a whole, they don't consider the non-error and error case to be pairs. Okay, because error case is not just a switch expression. Let's see what they have. Let me see what you wrote first. Printing is generally hard-coded in the compiler because the languages are not able to produce optimal enough code if it were implemented in them, or it is impossible. Even languages like Rust, C, or C++ have it hard-coded in compiler. Yeah. Zig did it in Zig. Yeah, I heard about that they like wrote the first or maybe first few versions of Zig in C, and then they used Zig to write Zig after. That's cool. Let's see what they do. Variable A, error, ABC. What is A? What is A in this case? Just the name of the error, right? The field. Then it's a union with the U32s, and they set it to 0. So this is a union error, error union. And then they dump the reference to A. So first of all, the reference so that it's considered to be mutated, and then dump to here because it's not used. That we don't have a compiler error because of this. Then const B equals if A. So if this is true, then capture group. Why this is in a different color? This is like this editor thing. Anyways, X capture group. So they add 3 to X. So then in the else, they have the error and they switch it. And they have these 3 cases. So the first is 0, the second is 1, the third is null. And then they expect type of B to be equal the optional of 32. And B depends on the A here. So it will either be this thing or one of these errors. Okay, because it's an error union with U32. So only if it's not an error, this will be U32 and an optional actually here, right? Okay. Then let's see what's next. This is a bit confusing to me, so it's very hard to follow it up. I'm doing my best, but not the simplest thing. The non-error and error cases are only pairs if the error case is just a switch expression. And what is different? The non-error and error cases are only pairs if the error case is just a switch expression, literally the same, right? So let me double check my sanity. Oh, it's a different. Oh no, they are the same. Yeah, okay. Sketch or maybe this is different. Yeah, this is different. So here they didn't turn rep x, here they did. So the pattern x catch error block switch error does not consider the unwrapped X and error case to be pairs. In the previous one, does not consider the non-error and error case to be pairs. So this case here and this case here, whatever, these three, they're not pairs. And in this case, X and error case. So I have to read first of all to see what they're trying to do. Constant C equals say catch error. Yes, so many different combinations of the syntax, like of these elements. Very hard to remember what is the correct. I mean, which are the correct, which we can use. So a catch error, switch error. So they switch the error here. If they catch while trying to do this, they capture it, push it into switch. Again, similar switch like before. And then, so it's the same like this thing here. They are expecting the same optional of U32. And did I miss something? No, it's everything is there. Because they're mentioning X. X catch. Okay, they didn't mean literally X. This is like A in this case. Okay, got it. I was expecting to see X. I thought literally X. But they basically say any variable followed by the catch and all these things. So in that case, the unwrapped A, so when they unwrap this, is not pair to the error case. Okay. Yes, so abstract to comprehend. Let me see what you guys wrote. They are trying to show a really hard thing. Yeah, that when Zig infers a type, it checks all possible values that can be put in it and decides based on that if the switch there is a single option that returns null. So the type is decided to be optional U32 because it needs to be able to support the null assignment. Yeah, I remember the null problem, or let's say complexity more precisely. Yeah, so I will definitely have to play with this a lot, and I don't think I will be capable of playing with these things in the next session that I will use to practice in, I think, in 2 days, like on Friday. I plan to do one more live coding session, but I think I will not do this then. So I will just watch, or at least read the description of the previous days after the last time I coded, and until the Friday day. So I will select something that I can play with, because this is a bit more advanced. So I'm not comfortable enough that I can play with this. I mean, I can play, it's not a problem. I'm not scared to show that I don't know, but I will just I think it's a waste of your time that I spend like 2 hours trying to figure out something. That's the idea. That's why not. Okay, so I don't want to start a new topic here. I think I will finish here with, let's say, rounding up this section, the pure type resolution, which is very interesting. But these last few examples are a bit harder to follow. Then these are the things that are next. So comp time. So basically what you said, yeah, this case study print is related to comp time, right? So it's under this section. So obviously maybe I will do that next. I don't know how many things are there. Let me see. Oh, this is so large text. I mean, this part first. The result location semantics. Let me see. And the next is using namespace. So let's see where this goes to a namespace. Oh, so many things. So here, yeah, so this will be, maybe it's not that hard. Maybe just like because it's a tabular data, it looks like large, but it's not maybe that large. And maybe it's easier to understand. I don't know. We'll see. Then using namespaces. So this is very short. So I believe it's possible to finish these two things, like result location semantics and using namespaces in the same time, at least to like on the higher level, if not to practice them, but on a higher level to see what they do. And then let's see the comp time. How large is it? So using the compile time concept. Okay. Then compile time, these three things: parameters, variables, expressions. So let's see how they have parameters. Variables, yeah, this is a bit larger. Expressions, so definitely these things only are much larger than these things together. Then let's see generic data structures and case study after this. Generic, where are the generic data structures? Yo, this is huge, these comp time expressions. Generic data structures, and then case study print in Zig. And what's next? Assembly. They are making syscalls, yeah, assembly calls. They go down to level of the assembly. And it will be interesting here if they are targeting a specific processor, so that you have to learn like the different dialects of few architectures, or they have something like a virtual processor that doesn't exist and they use the assembly for that one. So kind of like the idea of a WebAssembly. So if they have something like that, it will be interesting to see. But yeah, let me just go back to the plan for tomorrow. So it looks like I can do this for now and maybe start this, like at least the first chapter, because these last two things are a bit longer. Let me see what you guys wrote. The assignments, yeah, that's what I read last. I think the type of C is inferred. It's not specified, but this is for the last example. Okay, it's not specified, but the compiler is smart enough to know what it must be. So give me just a second to go back here. Yeah, so the type of C is inferred from whatever happens here. Compiler is smart enough to check all the possibilities of the switch, and also if it's actually going to go inside of the switch, if there is an error or not. And it covers all the possibilities and then infers the C. Yeah, that's cool. Otherwise it would complain. Yeah. Panic. I would even avoid this stuff for now. So maybe comp time would be nice, but might be too complex in the docs to understand. So let me just then double check here. Comp times. So maybe then I do these and I jump to generics and case study print, so that I avoid for now these things, comp time. So this is inside of comp time, but maybe it's understandable on its own that I don't need these things before to understand it. Cool. So probably then tomorrow I will do these. And then I will do these maybe even tomorrow if I make it in time, or then the day after. So this is day 18, so 19 for sure this, maybe even this. If not, then this day 20, and then a recap. And I will then do one last time tic-tac-toe. Yeah, there is something flying here. Sorry, one last time tic-tac-toe, so that it's even more abstract and that I try to use most of the things that I can at this level from these last few days that I spend learning further. Maybe content would be okay. It's based on the comp. It's based on the comp time. Comp time better before. Okay, thanks a lot. Okay, so then at least I will try to start these concepts on Friday, right before the recap, and definitely I will not use it in the recap. So I will then use probably up to tomorrow what I learn up to tomorrow on one more less time optimizing and playing. Not optimizing, actually. This is now more about practicing things than optimizing the actual tic-tac-toe game. And I still haven't installed anything on my machine, so I'll try really to do that and make this outside of streaming tutorial, because of what I explained. I will try to record on multiple operating systems and just like to have something that is like a comprehensive guide. I know you said like it's easy, but it's mostly the same on all the system, but just like I don't like to say something if I don't personally, literally, if it's print one, I know it should work, but I kind of want to stand behind my words that if I say this works, that I tried it. So kind of like I guarantee that works from my point of view. So not that I don't trust docs or uh, anything like that, but simply just like so that I can be able to say I trust, sorry, I not trust, I tested this myself. So this is what I saw when I tested it. Might be better to recap tic-tac-toe before continuing forward. Yeah, definitely. Just test the stuff up. You probably won't use comp time in the tic-tac-toe. Yeah, I think so. There is not much of. I mean, I can create some abstract example that I can then implement, like the board or something. I don't know. These characters or something like that at comp time to play with them, but I have to create some very weird structure so that I can actually practice this comp time. So probably, like you said, would be the option. Yeah, I'm curious to see how generics work here. So I love them in other programming languages. They basically offer you so much flexibility, and they're so useful. And I hated them in Java when I started because they're like the first time I've seen, and actually it's in C++. It was the first time I think when I don't remember. Actually, it was so long a time ago. But Java or C++ is the first time when I saw. I don't even know if C++ has generics. For Java, I remember because I worked with Java. And C++, I've never worked. Just like had C++ on my university, and I never use it professionally. So I forgot immediately after the exam. That's how it is usually if you don't use something. But you can try to write some simple data structures that would comp time. Yeah. That's a good idea. I will try that. Definitely. Okay, we have a plan for tomorrow. So result location semantics, both these subsections, and then using namespace. And I will try to scratch at least comp time, the introduction to it, if I can. And we are going to go from there. Unfortunately, you would want to visit Zig links before that, so you can understand the way to do heap allocation Zig. Okay. Yeah, so it's becoming increasingly difficult to keep track of these things in the docs only. So sooner or later I will have to use additional resources, not only here, reading the docs, and I will have to slow down as well. So I'm not only just like, I'm trying to cover most of the topics as fast as possible. So this is my in general, my principle when I'm learning something new. So I go kind of shallow for the first pass, just to have an idea what is there and what exists, even though I will forget a lot of these more complex things because I don't practice immediately. I do try to practice as much as I can the things that I understand so far, but at least I go through shallowly go through most of the topics so that I have a general idea how the language works, and then I go one more pass much slower later and practice more. So like it takes time, so you cannot master anything in 30 days. That's not the idea that I become a master of Zig. I don't have illusions that this is possible, but just like to go through all these things. And then for the deeper understanding, I will definitely have to do larger projects. And I have this, give me just a second to find, if I can, here the image that I used at the very first. Yeah, this thing. So basically this is the line. So the more time you spend on learning something, you will need to practice more. So basically this surface that is below this this curve is the time that is dedicated to practice, and this above the curve is the time that you spend the percentage of time. So let's say if I use 1 hour, how many minutes I will use, or let's say in this case 100 minutes to be easier to calculate how much minutes I spend should spend at least ideally on theory or on practice here. So the more you advance, you will definitely need to spend more time on practicing, and that's the fact. And I'm kind of here with Zig now, so that's why I have maybe 60% of theory, reading the docs and practicing just a bit as I can. But to actually get to this level, because this is not showing your knowledge, this is more like optimizing the workflow, but it is kind of correlated to this line. So your knowledge will be close to this line. So depending from case to case, but it should follow this line. If you are, of course, if you are somewhere on this line, if you're organizing your time in this way, then it should closely be related. So you should learn more if you practice more. And it should be closer to, let's say, if you then consider this not a minutes like what it is on this graph, it's actual time you spend on something. But if you just like in your mind have a parallel graph where you put the percentage of the Zig, in this case, you learn. So it's never going to be 100, but it's going to be, the more time you practice, it will be closer to 100, and it will be harder to to get all the details and all the complexities. And of course, they will change the language, so you will have to relearn and plug in these other new features and rethink of a lot of things and the chain reactions that they will cause with this. So I don't think they will have a lot of code breaking, compatibility breaking code changes, but they can change a lot and they can influence on some specific topics. So depending on what you want to focus with, that's about how it's going to look like. So yeah, I'm kind of here. So I do a lot of theory. I'm trying to push as closer I can to this line that I practice as much as possible, but simply because I don't even know what's there in Zig, I cannot practice something that I don't know if that it exists in the first place. So that's the problem when you're here. That's why a lot of people quit when things get harder. Then people quit. Let me see what you wrote. Sorry, I like talk and I forget to read the comments. Yeah, Ziglinks is the last thing that I read. I think that if you jump to Ziglinks after the recap and finalization of tic-tac-toe, you will fly through them. But read all of them. And try all the stuff you read about. Yeah, definitely have to try. And after getting Zig on your computer. Yeah. Andre, hello Andre, welcome. Since Zig is pretty new language, most of stuff you can learn you won't get from official materials. Yeah, so like the hard way, like breaking your fingers and mind. Most of stuff you can learn you won't get from official materials, since people invent new idiomatic ways to write programs all the time. Yeah, that's true. So true. All right, guys, I think I will stop here for today. Thank you all for being here and for help that I got from you guys in the chat. So I will be back here tomorrow, day 19, regular day. Now, no coding practices or anything like that, so just a regular day. Thank you guys. Have a nice evening, or depending where you are in the world at the moment, nice day or something else. And see you tomorrow. Bye-bye.